So today's session, this will be very specific towards glass, called glass as a building material. So today's in modern architecture, glass has been effectively utilized for the facade. So we call that as, instead of engineering, we call it as imagineering, where architect's imagination has to match with the design and the facade, the glass. So it is very clear that today's architecture very precisely need very different and unique aesthetics. We can even call it as signature designs, or they want it to be a material which is used for envelope, which is very flexible in the sense of various options to be evolved in using the material, and the robustness in the time of in the way it has to be getting constructed, whether it can be the speed or the availability or the replaceability has to be very robust. So this creates a lot of challenge in the functionality of the structure. Still, we would say the future is unexplored, because there will be huge involvement or in the development has to happen in the facade engineering, which will end up in giving up a lot of interactive buildings, or we can even call it a self-sufficient building or a net zero building. This is all possible if we can spend a lot of time in basic understanding the material that used for construction, especially the glass. Today we need to understand very clearly, before the project going to come up, based on the material used. Say for example, if glass going to be the envelope material of a building, then we need to understand this material by design, by analysis, by the need, by benefit it going to bring in, or by the function it going to execute during the process of construction or even after the construction process. Unless we are not able to understand any of these parameters, then there will be a challenge in handling glass as a building material. Why and how? I'll take you through. Because today's modern architecture, you can see as the pictures below, there is a huge challenge in the way it has to be visualized, whether on the colors, whether on the style, the texture, the shape, or the multifunction, because now we are looking forward to have a facade which has to be used like a digital media, or it has to be dynamically controlled. So all these functions has to be integrated in the initial phase of design. Why glass as an envelope material, or why we wanted to understand glass as a building material? Because glass has its very unique advantage when compared to any other equivalent envelope materials. There is no equivalent envelope material, I would say, because glass is about 1/10 lighter than any other available building envelope material. On the construction side, if you take the time that it's going to construct a envelope with glass, it's going to be extremely economical, because with the current technology, even there is a possibility to glaze 2 to 3 floors per day. Then the dependency on the labor is a huge challenge for today's construction. Whereas in the glass buildings, glass structures which is moving more towards factory made products, which can make it viable, or no need to have a dependency of the skilled labor at site. So there is a factory made product which is going to get just assembled or hooked at site. The major most important advantage of glass, it's the envelope thickness. The traditional building material, which is more than 300 to 400 mm thick, to achieve particular performance values and plus an envelope as to behave as an envelope material, glass can simply does that with 24 mm thick double glazing unit, or worst case it can go up to 30 to 35 mm thick. This has a huge impact on the overall carpet area. There is a scope to increase about 4 to 6% on the usable floor area if glass can be used as an envelope material. So ideally it increases your more usable area. So who are the key stakeholders in glass industry? Yes, ideally it's an architect who imagined the building. Yes, there is a consultant who guides us and helps us to identifying how to and what kind of glass has to be selected. Then the execution or the fabricators who going to execute or erect the glass at the site based on all the different design constraints, and the developer or the builder who going to invest money on the building and the envelope material, and finally they are going to maintain the building or going to sell the building, in whatever the case, how energy efficient or how green the entire building is going to be. And all these four important stakeholders in the market has a huge or different needs, I would say. When I go with an architect, he would be always looking for a very futuristic design, or he wanted to challenge his own design and come out with a very new, unique design. The safety is a major constraint for them to achieve when glass brings as a material. What is the eco-friendliness they are going to make with the building, or the footprint, carbon footprint the building going to make, or what are the new shades? They wanted their building to stand out from the crowd. So what is the new shade they can go on? When the consultant comes into picture, whether it can be a green consultant or can be a facade consultant, they always look for a reference of international quality, both on the production and both on the execution and both on the supply of materials. There is many projects nowadays has a huge challenge in achieving the acoustics. With the current speed on the construction happening, or even we have a group of projects near airports or the hotels near airports, has a huge challenge against acoustics. Safety again is important aspect that consultant wanted to address always. Fine, of course. Finally, the cost and the availability, which is the local sourcing, been a very important parameter for them to select any glass manufacturer. When it goes to the fabricator, the glaziers, they always worry about the international quality products which is tested on various laboratories, or the availability, perennial availability of the materials around the year, and how effective their design when compared to the availability of the standard sizes. So from the standard sizes currently, even the jumbo sizes are getting produced. So how effective or the usage or the yield can be improved. When it goes to the developer, he much worried about the sustainability factor, or the footprint, or the eco label, or the cost, the overall cost of the facade. What are the ways that they can save money, or how they have to effectively invest on glass and how the savings can be measured. So getting more deeper, glass, to understand glass, to start with, the glass is a basic float clear glass which is manufactured, and we can have tinted glasses where we can add coloring agents to the base float glass, where I can produce green, blue, bronze and grey. So this is ideally the base glass. This can be used for a coating purpose, or this can be then after coating it can be processed, and the same process glass get executed for the site. So getting into the coating technology, as a process, if I say the base glass manufacturing, which is a process 1, then the coating happening, which is a process 2, then the processing, ideally I am doing some value addition on the structural property of the glass, which is a action 3. So in this first, which is a float glass, as we all know, it's a very old technology where the glass has been, the basic raw materials are being grinded, fine grinded, placed into the furnace at a very high temperature of about 1600 degrees Celsius. The complete material gets into the molten liquid state. From there it has been poured into the bath, which is ideally called the float bath. The name comes because here the glass as a liquid material is floating over a material called tin, that's why it's called float glass. And then by just controlling the temperature, the glass is able to get its size, its thickness, and then it is allowed to cool on its natural process, which is called the annealing process, which is the third process in glass manufacturing. Once I do this, then I have to decide whether I am going to do the coating on the line or off the line. On the line, as it indicates, during the float glass manufacturing process, when the glass is going to exit the float bath and before it going to enter into the annealing layer, I have to apply a specific metals and oxides in the form of vapor to get deposited on the surface of the glass, which is called the online coating technology, where by this coating technology, I can make a product, whether it can be a solar control or it can be a thermal insulation or a Louis glass. In case of offline, as we see, as the name indicates, it is off the line, means the coating has to be done precisely in a separate location where you have multiple chambers to have a different materials which can be deposited on the surface of the glass to achieve a particular color, particular performance, particular reflection values, or even to particular solar factor and U values. So how do we decide what kind of glass to be produced, and how do we decide what kind of performance is requirement for different parts of the world? Say specific about Asian countries, our climate is very unique and very different compared to the rest of the world. We can say our climate is very typically a hot and humid climate where you need a glass coating which can help you to reduce the as much as heat that going to or trying to enter into your building. So based on the different climatic condition, there are different products are getting manufactured like solar control and thermal insulation glass. As the name indicates, solar control is where you have a direct solar which going to allow you or it going to penetrate more heat into your building has to be addressed, then it is solar control glass. As the name indicates, if it is a low E glass or thermal insulation glass, then we are going to play with a difference in temperature which is ideally not the climatic condition for India or even the Asian countries. So what is the challenge in India we have? We have two different challenges. One I would say the light, another one we say the heat. When you calculate the amount of energy spent in any building, 40% of the energy is spent on cooling the building and 25 to 30% of the energy is spending in giving natural light to the building, and remaining 30% is left to the occupancy load and the other internal heat loads, which is because of any other electrical appliances. So the 70% of the energy which is spent, which is because of the contribution through your envelope material, which is your light and heat. Even though as a country we have enormous light, still we spend heavily on artificial lighting. And similarly on the other side, we have a source called sun which is going to allow lot of heat into your building, so you are going to spend lot of energy on cooling the space. So what is a common material which going to address both? It's ideally the glass. That's why glass became an modern envelope material, I can say. Moment I say glass as an envelope material or a building material, the important parameter it has to be addressed is the light transmission and the heat transmission portion. So to understand, when you select a product, there are three important parameters we are supposed to go through or we are supposed to understand before selecting glass. One is the light transmission, another one is the direct heat transmission, the third one is the indirect heat transmission. So what is light transmission? The percentage of light that pass through the glass and going to reach into your entire inner space of your building, the percentage of light transmission happening through the material is called the light transmission, visual light transmission of a glass. So what is a traditional mistake I would say we'll be doing? We have a clear float glass, 6 mm or even 5 mm thick, which has a light transmission of about 89%. If you see through here, the problem we can understood very clearly is, based on the color code, the more yellowish means there is amount of the lux level which is above 4000 is more in the zone. What it indicates? It indicates that when the light transmission happening, the depth of the light penetration is restricted as much as to 1 to 1.5 times of the height of the window. So the entire that zone is going to get accumulate the amount of light coming in. That's why the average light lux level is very high and even the peak is going up to 9200. The ideal light transmission level, lux level that we can hold it or we can be comfortable inside the space has to be around 2000-2500 lux max. So this is the traditional mistake we do. We have a clear glass, 5 mm or 6 mm, which has very high light transmission, say like 89%. 89% to what? 89% to about 1.1 lakh lux of light, which is a source. So when my glass has a tendency to allow 89%, which is approximately we are going to get 1 lakh lux inside the space. 1 lakh lux versus what I need to read and write, it's hardly 500 lux. So there is a huge gap between what I need and what my source is going to give me. This will create glare. Anything more than 1:10 ratio will affect the comfort of your user. How can I address, or currently what is the solution I have? I will have a different kinds of blinds which going to cut the light. But am I going to cut the light alone? No, I am going to cut the complete visibility. Any building, when it is being designed, the basic need to design the building with glass is for two. One is to have a see-through or the transparency for the inner occupant to see through the external world, and the second one is the light transmission, so that the natural light comes into my space, which has huge impact on individuals' comfort and productivity, even on both physical and psychological actions. How can I address it now? I don't want it to cut the light completely, but I cannot have a glary situation. So that's where this kind of high performance glass comes into picture, where I can have a glass which is with ideally 30 to 40% light, just for this example, if you can see here, I have a light transmission which is at 40%, which has dropped the entire lux level, whether it is both average or your peak lux level to an extent, so that now I am going to give the same natural light, but the intensity of the light is lower, so that you no need to worry about as a disturbance without glare. One more design aspects I can bring it to you is, traditionally we don't want to have a larger windows, because we believe moment we increase the glass area, I am going to increase more heat coming in. But with the today's modern sophisticated products available in the market, I have a window wall ratio about 16%, which is I need to spend about 4.2 kilowatt hour of electricity consumption. In the same building, I have a provision to increase the window wall ratio to 25%. Still my energy consumption is lower, because I can have a solar control glass which is going to cut the heat, and the amount of heat coming in is less inside, so automatically it has a huge impact on the overall energy of the building. This is another important parameter to be addressed when it comes to light transmission. So what are the other things that we can do to create a better environment? One is, we should understand what is ideal light transmission or marginal light transmission. When I use a very high light transmission glasses, it will end up in giving a extreme visual discomfort, which is called glare, or it will promote you to, or it will create a habit for you to have a different kinds of blinds, curtains, and it will improve your artificial lighting. End of the day, having a glass getting defeated. How to understand what is the impact when you have a marginal lighting? It will be very soothing, and still you can enjoy the natural lighting. You can control glare to an extent, and the functionality of the glass, which is going to blend the interior with exterior, that's all still alive. So there are a lot of other ways, even though if there is a requirement to have a higher light transmission in a project as a design intent, there are other ways to address this constraint of higher light transmission. For example, we can have a simpler ceramic dots or stripes on the top surface of the glass above your vision area, which can help you to block the direct light coming in, still it allows diffuse light getting into it. Or you can divide the vertical panel, vertical facade into two panes, one as a daylight pane and another one as a vision pane, so that the daylight pane can have a higher light transmission glasses and the vision pane have a lower light transmission glasses, so that the people occupying near the facade may not have any disturbance due to light, but still there is a daylight pane with higher light transmission can allow the light to get deeper more.